I have been thinking about it for a long time, and now is the time to start the Digital Pathology Place Journal Club. And I'm going to have a special edition here because it's going to be about a paper that I was the first author on, and it's developing a qualification and verification strategy for digital tissue image analysis in toxicological pathology. So let me tell you the story about this paper. I was working in a digital pathology image analysis company, and I was the first pathologist there, and I was developing a QC strategy. I wrote it down, and it was supposed to be a part of a book. This book was never published, but I had that manus. And then there was a call for papers for the special issue of the Journal of Toxicological Pathology about digital pathology and image analysis. So perfect, right? I have the manuscript and it can be published. So I only need to find a couple of co-authors, right? So I reach out to colleagues and friends that I know have been working in image analysis for quite some while and ask them, okay, do you want to be part of this? I have this almost ready, right? So it's going to be a piece of cake. Luckily, they all agreed to work on this with me, and I sent out the manuscript for review, and I get it like totally read, everything read. So obviously what I wrote down was my experience and my way of looking at the different things. So it was totally one-sided. So here, a big, big shout out to all my co-authors for bringing this paper to what it is right now, to a well-rounded description of, I can say, industry standards. This is how we are doing this in the industry. So thank you very much, Famke Effner, Mike Stau, Daniel Brown, Thomas Westerling-Bui, Dan Radman, and Robert Klopfleisch. And they're not in the order as they are in the paper. I will leave the link to the paper. In this paper, we include perspectives from different areas, from academia, from CRO, from pharma industry. So it is being viewed from different angles. So let me sum up the most important things of this paper. Obviously, we give introduction to the subjects like you have to do in every paper. And different factors that impact digital tissue image analysis are mentioned here, as well as bias. I think bias is something we very often underestimate in image analysis. We think this is already a quantitative and objective method. No, there's a lot of bias coming into that method. So we have to be aware of that. And this is in the paper as well. We talk about the aspects to consider before starting digital image analysis. But the most important thing that we give in this paper is proposed QC methods of image analysis results. We propose a workflow here that has worked for us, that is now a validated workflow. So there are three main things that you want to control the quality of. First, you have to identify the regions you want to do the analysis in. Then you have to identify the objects and be sure that all these objects that are of your interest are distinguishable from all the other objects. And third, if you have any measurements on those objects, you have to check that they are correct. And there is a framework we use to get to that point. The process that we use is that three people working on that algorithm development have to agree. And those three people are usually pathologists or pathologist-trained designees that are responsible for three aspects. The first aspect is the design of the algorithm itself. The second aspect is the quality control of the algorithm. And the third aspect is the quality control of the output. So the first person working on it is a designer. It can be one person or more people can be designing it, but at least three different people to take care of those three aspects. So the designer is designing the algorithm and he or she is checking the performance of the algorithm and measuring it with the loss function. The loss function should be close to zero. on the training data. And obviously, it's going to be a little bit worse, so further from zero on the testing data. This is to be expected. But as soon as we get this as close to zero as possible and the designer is satisfied with the design of the algorithm goes to the second person that is reviewing the algorithm itself. And the second person, pathologist or a scientist that is trained in this, is reviewing basically all the decisions that were made when designing the algorithm. He or she has access to all the data used for the development of the algorithm and everything that may be needed to evaluate the decisions that were made. So it's basically QCing the process of the development a little bit and how the algorithm is working, not the output yet. So if the second pathologist or the second reviewer does not approve the algorithm, there is some flawed logic or something is not wrong, we go back to bench and we start redesigning. Once it is approved by the second person, it has to be documented, versioned, and saved in secure location. And then the third person starts reviewing. And the third person is actually blinded to the way the algorithm was designed. The third person is only reviewing the output of the algorithm. And it can be basically done in two ways. The first way is by annotating structures and comparing the performance of the algorithm to the structures annotated. And this has the advantage that this is quantitative. And if we have automated tests that can be rerun on different versions of the algorithm when it's improved, then there's no need of providing those annotations again. But the disadvantage is it is something that is time consuming and the pathologist has to be trained on the system, how to provide annotations. And obviously we have to have annotation guidelines in advance. The second way is visual QC. So visually, we assess the performance of the algorithm. And the advantage here is that we don't have to be restricted to regions of interest. In the previous method, you're not going to annotate the whole slide image. Unfortunately, this is not feasible. But in the second method, the visual QC, you can evaluate the whole slide. You can evaluate the performance of the algorithm of the whole slide. So this is an advantage. Disadvantage, obviously, it is not quantitative. It's qualitative, and it is subjective. We need to define the acceptance criteria in advance for both methods, for the quantitative and the visual method. This is the part of the process. And sometimes we can use a combination of those two methods. So this is the framework we use at Charles River Laboratories. You can read in detail about the context and about how exactly it's done in the paper. Thanks again so much to my co-authors and see you in the next journal club.